Eighth graders, welcome to the first lesson of Chapter 4. Chapter 4, 1A. Now, you are going to find that throughout most of Chapter 4, many of these lessons are things that you've done before. Some of them going all the way back to 6th grade. Today we're going to be talking about divisibility, as well as prime and composite numbers. If you recall from divisibility, you have divisibility rules. And according to the definition, a number is divisible by a second number if the number can be divided by the second number with a remainder of 0. In other words, let's say that we have a number. We're going to find out, can 2 go in there evenly, can 3 go in there evenly, etc. The tests for 2, 3, 4, 5, 9, and 10 are listed in the table. You've had these tests before. For 2, we're going to look for even numbers. If it ends in 0, 2, 4, 6, or 8. In the test for 3, we're going to find if the digital sum is divisible by 3. Remember, that means we add up the digits that make up the number. If it comes up to a 3, a 6, a 9, a 12, or a 15, then we know the number is divisible by 3. In the test for 4, we are only going to look at the last 2 digits, tens place and the ones place. If the tens place and the ones place form a number that is a multiple of 4, like 0, 4, 0, 8, 1, 2, 1, 6, 2, 0, 2, 4, then we know that the whole number is divisible by 4. The test for 5 is pretty much, people remember that one. It either ends in a 0 or a 5. And the digital sum for 9, or the test for 9 rather, is very much like 3, only instead of asking if the digital sum is divisible by 3, this time we look for it being a multiple of 9, such as 9, 18, 27, 36, etc. And of course the test for 10 is very easy. We simply ask ourselves, does the number end in a 0? One of the things you'll be asked to do is to decide whether or not a number is divisible by the second number, and then to explain. Let me make it very clear that the explanation for A, for example, is not 465 is divisible by 5. We are looking for a summation of the divisibility test. So if we look at A, yes, it is divisible by 5 because the number ends in a 5. If we look at B, again, we need to look at the number formed by the tens digits and the ones digit. That's a 64. If I can take 64 and divide by 4 and have it work out evenly, then I know my whole number will be divisible. And it is, because 64 is divisible by 4. 4 times 16. Now, C. This is where we get into the digital sum. We need to take 3 plus 3 plus 0 plus 0, and our digital sum here is going to be 6. There's no way that 9 goes evenly into 6. In D, here again, we're going to be testing for that digital sum. So I take 5 plus 1 plus 4. A lot of people skip the 0 because it's not going to change anything. So I would too. And you're going to get a 10. 3 does not go into 10 evenly. So therefore, 5,140 cannot be divisible by 3. Then we're going to move right on to prime and composite numbers. I'm going to remind you of their definitions. Notice that it says it's a whole number greater than 1. 1 is not prime, nor is it composite. Because again, look at your definitions for both prime number and composite numbers. Both of the numbers have to be greater than 1. For a prime number, you're only going to have 2 factors, 1 and the number itself. If we look at a number like 3, the only factors of 3 are 1 times 3. If we look at a number like 17, the only factors of 17 are 1 times 17. However, if we're going to go to a composite number, that means it has more than 2 factors. So we are going to take a look at a number like 4. Now this goes back to listing factors like we did back in 7th grade. You can have 1 times 4 and you can have 2 times 2. So the factors are 1, 2, and 4. Okay? So what you're looking for too is if a composite number, one of the ways you can do this is to ask yourself, will any of my divisibility tests work? And if they do, you know you have a composite number. 12, for example, has to be composite because it has factors of 1, 2, 3, 4, 6, and 12. So it has to be a composite number. Testing for primes or composites. Here again, repeat, the number's going to be composite if any of the divisibility tests work. For example, I take 188, I look at that number and I say, da-ding, it's an even number, therefore it has to be divisible by 2, therefore it has to be a composite number. And I do go through and test with divisibility tests for 2, 3, 4, 5, 9, and 10. Now, what happens if you test for the 2, 3, 4, 5, 9, and 10 and nothing works? You cannot automatically assume that the number is prime. Then what we have to do is called dividing by primes. And we start with our smallest prime for which we do not have a memorized test. And that's going to be 7. Then we try 11. Then we try 13, 17, and 19. Or we go until the quotient is going to be less than the divisor, and I will show you an example of that. In our first example, we have 275. That 5 should pop right out at you. Since it ends in a 5, that means our test for 5 will work. Ends in 5, so 5 goes into 275. That tells us automatically that our number is composite. Do we write down ends in 5 so 5 goes into 275? No, that's done mentally. What you write down is the C for composite. Okay, B. Hit pause. Try it. A lot of people miss this one because they think, oh, 57's got to be prime. But if you try your tests, you will see that 3 goes into that number because 5 plus 7 equals 12. So 3, I call it 3 works. Therefore, 57 has to be composite. 51 and 57 are both composite numbers. But many, many students tell me they are primes because they do not take the time to actually do the divisibility tests. Hit pause again, try 71. Okay, did you notice that it failed, quote unquote, all of the divisibility tests? 2, 3, 4, 5, 9, and 10 just simply don't work. So I have to test with these primes or divide by the primes. So I start with 71, divide by 7. I get a remainder of 1. That's not going to work. So then I try 11. I was sitting there 6 times, 66, minus, take it away from 71 and get a remainder of 5. Now, notice, here's my quotient, here's my divisor. My divisor is greater than my quotient, and it didn't work out evenly. You are not going to find anything that works. So this has to be a prime number. And that concludes Lesson 4.1a.